Welcome, third graders. This is Mrs. Friedberg, and today we're going to continue to talk about key details and main ideas. What you're going to need is a pencil, a benchmark reader, forces and interaction, and your benchmark worksheet, page 15. The directions on page 15 tell us to read paragraphs 7 through 11 of Investigate Magnetism. We're going to take notes and annotate key details, and then we're going to complete the chart with key details and main ideas. We're going to go paragraph by paragraph. So turn in your reader to page 24. Looking at paragraph 7 first, read to yourself as I read aloud. Metals, like all matter, are made of trillions of tiny particles. These tiny particles are called atoms. Inside each atom are even smaller particles. Electrons spin and float around the nucleus inside the atom. In cases where there are unpaired electrons, the electrons group together. These groups move together in one direction. This is what causes the magnet properties in certain metals. So, metals are made of atoms. We definitely want to put that. And inside each atom, there are electrons that spin around the nucleus of the atom. And when unpaired electrons, they group together, so making north and south magnets. So if you look back on page 22, you see a magnet with two different sides. One is south and one is north, and they attract different groups of electrons. It's kind of like fish swimming, the south-going fish and the north-going fish, all grouped together to have different type of magnetic poles. So these groups move together in one direction, and that causes the magnetic properties in certain metals. So definitely that. So we have 5 items that we have noted that are important. So let's look over at our key details and main ideas on page 15. A couple things we want to note are that metals are made of atoms. Also, that electrons move around a nucleus. Hold on, I gotta spell that right. N-U-C. And also that unpaired electrons move together. And this causes magnetic properties in certain metals. So we're going to say creating magnetic properties in certain metals. Remember we talked about that steel and iron and things like that. So for the main idea, we're definitely going to have magnetism is caused by electrons. Because it is telling us what is creating a magnet, right? Excellent. Moving on to paragraph 8. Read to yourself as I read it aloud. When the forces of electrons are unbalanced, certain metals will have magnetic properties. Iron and steel are two such metals. You can explore this yourself. First, get a piece of steel. Next, rub the piece of steel in one direction repeatedly with a magnet. This will affect the electron particles inside the metal and magnetize the steel atoms. Finally, test and observe the steel's new magnetic properties. So, I just experimented with this recently when I was putting together a door in my girl's room. So I put the screws on the magnet that's on the base of my drill, and the magnet created a magnetic force in the steel screws that when I attached it to the drill head, the screw stayed in place like a magnet. Super helpful. So let's look at key details and main ideas for paragraph 8. So, unbalanced forces and electrons. Iron and steel have unbalanced forces. Magnet magnetizes steels and by charging their electron particles. So there are unbalanced forces and electrons. And also that it is in iron and steel that have these unbalances that allow it to become magnetic. So, iron and steel have unbalanced electrons. And that's why we can create a magnet with those metals. So, for a main idea, let's have certain types of metals can be magnetic. Excellent. Let's look at paragraph 9. Read to yourself as I read aloud. All magnets have what is called a magnetic field. Ooh, definitely. I'm going to star that as well. This area of a magnetic force is generated by an unbalanced electron particles inside the metal. So definitely, this might even be star here. Magnetic fields and their forces are invisible. However, the effects of their power can be observed. Magnetic fields vary in strength. For example, a weak magnet may slide down the front of the refrigerator when placed atop a piece of paper. Meanwhile, an industrial-sized magnet can lift a refrigerator 20 feet into the air, kind of like the one that we talked about yesterday, the crane operator with its electromagnet. So, magnetic fields vary in strength, absolutely. And we can observe their the effects, but we can't really see the magnetic field. So the magnetic field and their forces are invisible. We know they're there because we can see them move objects. Excellent. So let's look now at worksheet page 15, paragraph 9. We learned that magnetic fields are invisible but can be observed. And that some fields are strong and some fields are weak. So we'll say magnetic fields have different strengths. So, what was that whole paragraph talking about? The main idea of that paragraph would definitely have to do with the strength of magnetic fields. So, magnetic fields can be very strong or very weak. Excellent. Let's look at paragraph 10. Paragraph 10, read to yourself as I read aloud. Typically, magnets have a north pole and a south pole. The power of a magnet is strongest near its poles. When two magnets are placed near one another, they are attracted to opposing poles. The north pole is south seeking. We definitely need to make sure we remember that. And is attracted to the south pole. So north is attracted to south, and the south pole is north seeking and is attracted, or the south pole is attracted to the north pole. So, as you think about that, look down here at this picture. So, we have a north pole and we have a south pole on our planet, and some magnets, so south magnetic pole goes up to the north, and the north goes down to the south. And so just like here, so these ones that are north, they want to go down to the south pole, and these ones that are south want to go up to the north pole. So if you've ever used magnets and you try to put them together when they have the two of the same sides and they're really tough to put together, that's because their poles or their polarity is the same. So when they say opposites attract, they are really talking about a magnetic field. So if the north pole of one magnet is placed next to the north pole of another magnet, the two poles will push away. So north pole and north pole will push away. The same thing will happen if the two south poles are placed next to each other. In other words, unlike poles attract and like poles repel. Earth has north and south poles too. That is because Earth is actually a giant magnet. Whoa, that is good to know. Earth's core is a turning ball of iron that produces Earth's magnetic field. Whew, that is super important. Great. Now let's look over at paragraph 10 on our key details and main ideas. So, north and south poles seek each other and repel when they are similar. So let's do The unlike poles of a magnet attract and like poles of a magnet repel or push away. Excellent. We also need to know that Earth is just a giant magnet. That is pretty cool. And why is it a giant magnet? Because Earth's core is made out of iron, and creates a magnetic field. Excellent. So the main idea there is definitely this first statement. So we could say like south poles, they like north, and north poles, we'll do 2 arrows, they like south, but south, they push away. So if we were to south and south repel, oops, so like poles repel and unlike poles or opposites attract. Excellent. Let's look at paragraph 11. Electric currents also generate a magnetic field. Absolutely. The most powerful magnets in the world are electromagnets. Most powerful electric magnets. The electromagnet uses an electric current to produce its magnetic field. Ooh, that is definitely important. The magnetic field disappears when the electromagnet is turned off. Oh, excellent. Great. So now let's look over at our last part of key details and main ideas. So definitely that electric currents have a magnetic field, and can create an electromagnet. Excellent. Here we go. So electric magnets use electric currents to make a powerful magnetic field would be the whole point of that paragraph, or the main idea, teaching us about electromagnets. So use electric currents to make a powerful magnet. Excellent. Looking down at the last part, why do some electrons group together? And choose a sentence from paragraph 7 that gives an answer to this question. So I am going to look back at what we wrote in paragraph 7. Metals are made of atoms. Electrons move around a nucleus. Unpaired electrons move together, creating magnetic properties in certain metals. And so magnetism is caused by electrons. So why do some electrons group together? So metals are, like all matter, are made of tiny particles. Electrons spin and float around the nucleus inside the atom. In cases where there are unpaired electrons will group together. These groups can move together in one direction. This is what causes a magnetic property in certain metals. So we want to remember that it is the unpaired electrons that group together. So why do they group together? Because they are unpaired. Excellent. I hope you do some magnetic investigation. It's pretty cool.